Well, this is the last repair left over from December. We have to start on January one. There's a couple of stragglers. There's that PE Ranger still to finish off from about 4 months ago. And we've got another straggler which has got PA problems. Keep putting 4 hours into it and getting a bit further. Right, I'll get this opened up. Rumour has it this is a Binatone Route 66, and I suspect it's the early version because my radio ham acquaintance would otherwise be able to sort it out himself, I would think. I don't care how awful these are, I like them. I probably like all the awful sets. Right. So he fixed it worse. That's fair enough. At least he says so. There's no point putting it on the test set and seeing what it does with it having come in, having been looked at by somebody else and they've not got anywhere with it. We know the radio isn't going to blow up on powering up, and we also know it's not going to be working properly. I forgot to put the soldering iron on like a twit. So which one is it? Oh, I'd hyped myself up for the early version. It isn't, it's the late version. Oh, I'm pleased about that. And he's quite right, there's no alignment instructions for the late version. The service manual only tells you how to align the early version. So, one of the things you don't touch is this. Someone once commented when I did a tune-up, "You never did this." Well, no, that's not part of the tuning, that's part of the I've got this in the background making a racket, the test set. This is all part of the harmonic trap, so that's aligned with the oscilloscope, with the spectrum analyser. I might do that on this one because with it having been messed with. Right, that can go on a piece of polystyrene. What power lead is it? Oh, it's a Uniden type. So these are made in Japan by goodness knows who. Clearly there's another market one with a relay there. It's in lovely condition. And the wiring for the microphone is Cybernet. So hopefully, oh no, it's a Uniden mic, it would be. I'm looking for the mic, a Cybernet mic, and there's one there all the time. So at this point we'll do the crocodile clips because I don't think I've got a Uniden power lead on here. There we go, that's lit up, it's on channel 20. So it's immaterial what it actually does, although we will look at that because we know it needs totally realigning. So I'll switch picture in picture on. And it's doing bang on 3.5 watts. I think that's about par for the course on these. Let's see what it's receiving like. Tell you what, we'll plug in the extension speaker, which is the one going to the instruments. So it is receiving 10 microvolts. So at the moment it's doing 1 microvolt for 12 dB synad. So, and he says it's off frequency now as well. Oh yeah, it's got such harmonics that it's actually transmitting on 24 megs. So we'll have to look at that with the spectrum analyzer, which I will switch on immediately. Just wait for that to come on, and we'll select that on the inset picture. That's not the right one. Camera 5. So if I put 27, when that boots up, I'll put in 2779125. Come on, boot up. Thank you. So there we have 2779125 in the centre. So we'll key it up, and you can see we've got let's just look at the peaks. Oh, it's such a lot at 13 megs at half the frequency, so it's really not feeling very well at all. Right, we'll come out of that. Right, I'll go and get a service manual, and I'll get our notes, because the service manual for these, as he says, isn't really relevant apart from an afterthought circuit shoved in the back. Right, I've had a look at the circuits and that. Now, the service manual is excellent if it was the early version, and for the late version, it's pretty useless. And that's what we're up against. So, although it has the circuit diagram for the late version in here, it also has the layout for the late version. The trouble is, the way this is printed, you can't actually see the components. That's the side we want, and if it was printed like that, you could read the components. So what you've got to do is kind of look at this. This is the other way on. This is the print side, so it's a bit of a pain. So we've got to see whether my notes can get us by. So we'll start. We've got these multiplier. You've got this AN103 IC, and this is a multiplier. So I reckon T9 and 10, which is here and there. What did he say? Yeah, he twiddled 9 and 10. So we key up. I suspect that's too low down. So what I'm going to do, I'm going to look at the spectrum analyzer. I'm going to put 2779125 back in. Otherwise I'd have to use a grid dip meter. I could really do with a crocodile tip lead. I'll tell you what, I'm going to use the grid dip meter. So I want the 27 meg coil. So this is 14 to 37. I'm just going to tune it with a walkie-talkie. I'm just going to widen the picture so we can hopefully see that. In fact, that's probably a better sniffing point. So I've got maximum there. There's actually 3 points at which it oscillates. I think we'll go for the middle point and we'll maximise that one. So I'm twiddling between 9 and 10. So it's still not coming up at 28 meg. I'll tell you what, I'm going to show you the, it's alright showing you the power. I'm going to show you my frequency counter, which will, so when I key up, you'll see we're getting 24.8. If I move that camera across, it's 24.8. So it's not on the right bit of the frequency now. So I've been adjusting 9 and 10 just there. I'm just going to go through some of the others and see whether it clicks into position, because they appear to be the peak for 27 megs. So it might be something else that's out of kilter. Could even be these only touch them if you've got a spectrum analyzer ones. Did he say he touched those? 2, 5 and 6. I don't know. So having done 9 and 10, we look at L6 and L5. which are those two. What about 11? What's that part of? I haven't got that noted. See what happens. Oh, it's this part of the transmitter. Let's move on to a bigger trimming tool. I'm going to look at these. I'm going to look at these here. He may not have fiddled with them, but somebody else might have done. I don't want to connect the radio direct to the spectrum analyzer. So I'm putting quite a minimal signal in. I think we'll just put a bit of a crocodile clip lead on there and see whether we can get a bit more into the spectrum analyzer, because I'm not getting a reading yet on there. Normally the sniffer lead I have is quite adequate from the position it's currently in. So on the face of it, we have max 27 megs on that, on the grid dip meter. Oh, that stubby bit of power lead might just get me a few more inches across. Okay, I'm going to put you onto the spectrum analyzer screen now. So we are on 2779125 there. So although my test set isn't picking it up solidly, I just need to maximise what we've got. I say the 3 points at which it oscillates. So I'm going for the best. So it is that centre one which I had it on before. It's just that this core seems to be lower down than I'd expect. So I'm going to re-twiddle it. I'll see what happens if I retune this one to there. It looks right, but it isn't right. Aha! That is right. So just again see which one I need to be on. There were 3 points at which it oscillated. That's the main one. It's the main one. And the power's right down now. So the radio's only now doing just over 1 watt, but we're on the right frequency. Let's see whether we can tune it up now. Wow, that's brought it up. So now we're at 27,79125 solidly, and it is now doing 1 watt. So we just need to make sure that high and low power presets are in the correct position. I never know which way round these are. So I'm going to go back to the power meter. I'll tell you what, we'll go past the frequency counter first. So you can see it's now 27,79125, and the power is 1 watt. We're on the 3 watt scale. So with 2 presets, we've got VR6 and VR7. I think 6 is high power. They might be lying. Yeah, it looks that way. So I've got that up full at the moment. And let's see whether we can tune up this transmitter. I'm going to have to do these trap things with the spectrum analyzer again. Let's go over to that. Just move the camera up a bit because we're going to the edge of the screen. They're usually right at the top. In fact, sometimes over the top. Because I suspect this filter was intended for the European market originally. So I'm happy about that. Just go through this transmitter again. So I'm now going to go looking at the RF meter. Again, make sure I'm on the right one. Now, I wasn't on the right one. This is why we're having problems. So straight away it's now doing 2.5 watts. 3 watts. Yeah, this is about where it should be. They don't do 4 watts, these sets. I don't think they do for a moment. So now, hopefully I can tune this up for maximum on the power meter. So let's see if I can. So that was correct. That's brought it up to 3.5. I'll go back to this one. That's solid. That really is solid. And back to this. Wow, it's doing about 4.8. So now we'll drop that with the low power. Oh, sorry, the high power preset. That's now bang on the 4. and the spectrum is correct. I'm just going to put on the spectrum analyzer 54 megs, so we're looking at double. So we'll just do that. I'll put that back on the spectrum analyzer. But this is what happens when they're screwed up and it's a more complex arrangement than usual. So frequency 54 megs. We'll key it up now. We've got absolutely nothing. Absolutely nothing. So that spectrum analyzer, doing it the way I've done it. So be clear, because it was transmitting on 24 megs, I've set my grid dip oscillator using the walkie-talkie as a reference point. I've set it to the frequency I want, 27.79125. So you've got to just twiddle it for the maximum peak on the walkie-talkie. I'll just show you that again. So I've got my walkie-talkie here, so you can see my needles moving. I've got the sensitivity, that is 27 megs. If I twiddle the knob for tuning, I can make that disappear, and so on. So what I then did, tune it up for 27 megs. For the peak, but I had to sniff it in the PA because there just isn't enough sensitivity to do that. And I couldn't get my spectrum analyzer without directly connecting it, and I start having to put in attenuators and things. So I've done it with this first. I've then, as soon as we've kind of had something coming out of it, gone to the spectrum analyzer, tuned it up for maximum, and then when it's stable on 27 megs, I've then peaked it for maximum, and I found that that core was in a totally false position. So that is now back where it should be. So I will unplug my grid dip oscillator. Just like that. So now, I haven't done the audio on this, of course. Just look at transmitted audio then. Let's go over to the main meter. Wallow, 1, 2. So it's doing 1.8. So that doesn't look like it's been twiddled with. I think VR5 is deviation. So we'll just run through that, just so I can listen to myself on this monitor receiver. Or on this talkie-walkie. So VR5, if I can find that. If I can find that. That should be RX meter. Is it? It's not that one at the back, is it? It is. Wallow. Wallow. That's it. I've actually had to turn that to full to get the deviations I want. So just check we're in calibration. 1, 2, wallow. Wallow. Yes, it's. I've just dropped that. The minutest fraction was just peaking at 2.6. Wallow. There we are, peaking at 2.5. So now I can listen to myself and give myself some feedback. Testing 1, 2, 3, 4, 5, 5, 4, 3, 2, 1. Right, a bit of a sharp AGC on these, a bit like realistic 1007s. So we've got 4 watts on high power. In fact, it's just as it's cooled down, it's just gone up slightly. So now we'll set low power. So at the moment, it's doing, well, I've fiddled with it, haven't I? It's doing, we're on the 3 watt scale, it's doing 600 and something milliwatts. We'll just drop that to 400 milliwatts, where it should be. I'll go back to high power and check that we're still on 4 watts, because these are interactive as well. Not quite. I've actually never seen one of these. I don't think I've ever seen one do. And that's do 4 watts before, and this is having to be turned down. I must have done something right. There we are. They're balanced perfectly. Now the meter on the front. What does the meter on the front say? It says 3, so we'll just adjust that, and according to my reckoning it should be VR4, which is that one, and that now reads bang on the 4 watts. We've got there. The transmitter's finished, and as usual these are either flush or just poking out, and you saw me do that on the spectrum analyzer. Now we'll have a look at the receive. So I was saying it was doing 1 microvolt as it's been presented, and that's not dreadful. Well, let's see if it's on frequency. That's another point. It is, and we don't have to adjust the trimmer capacitor there, so it's already spot on frequency, so that's fine. Right, we'll put a big hefty signal on. I'll switch the spectrum analyzer off and save myself some electricity and the fan. And we've put 100 microvolts. I'll put the oscilloscope on. We'll wait for that to warm up. There we go. Put a bit of volume on so we've got a decent trace, and I want to just do the detector. And I reckoned that the detector's T4. Well, it's going to be that one, I'm sure. And that was absolutely spot on as it was. So we'll go over to the synod meter. I'm trying to remember to move the camera across, which one day I'll reset the position of. So we want about 4 dB there, and it's T1, T2, T3, T1, T2, T1, T2, T3. No difference. No difference. Put a bigger signal on for that. And that. Let's go back to a smaller signal. One of these affects the squelch. It could be that one. I think T5. Yeah, that affects the squelch, believe it or not. Now we've got another one to fiddle with, and its injection is T6. T6 is the 10.24 coming out of the phase lock loop master oscillator, and it goes into the IF as its reference. So now we've got this half decent, we can tweak that. So that seems to be the optimum. We've actually got it down now to 0.52 microvolts. So, you know, that we're not going to get better than that. That's fantastic. So you've got the front end being those two, the IF being that, the detector being there, and this being the 10.24 injection into the IF. A bit like the way the LCL communicator in I440DX and others using that chassis is. This does appear as a Eurocom radio as well. Is it the DX40? So, Squelch is a faff and a half on these. You've got 3 adjustments. I think it's another one, a bit like the Fidelity 1000 that uses an AM detector to do the squelch. But don't take me for gospel on that. Now, squelch. Well, that's where you'd expect it to be. Let's put 100 microvolts on. You know what? He's spot on. I'm just going to set threshold. I've got 3 microvolts on. I'm just going to twiddle this coil. I'll just go back to the cyanide meter because I may be lying. That's back where we were. I can't see an effect, but I understand it's part of the squelch circuit. So, that is perfect. However, you've got VR1 and you've got VR2. Now, VR2 is the normal squelch preset, and as I say, that is perfect the way it's set. So that means that VR1 is that one, which appears to be the minimum squelch preset. I don't need to mess with that. Because the squelch is coming in where you'd expect. Let's just go to no signal. Oh, hang on a minute. No, we've got squelch on all the time, so we need to adjust the minimum one. So I want it to actually hiss when there's no signal. There we go. Switch the signal generator back on. It's parked at 0.3 of a microvolt, and let's see where it comes in. So it's coming in at 0.32 of a microvolt, and it's leaving at 0.24. So I'm glad that came up. So if you've got a situation where you've got the squelch down, you've got no aerial in, and it's not sat there hissing at you, the minimum is that preset there. So just in case you're interactive, we'll just recheck our maximum squelch. So I'll put the signal generator back on, we'll turn the squelch to full, and then we'll go through the attenuator, which I'll put on screen. So 1 microvolt, 3 microvolts, 10 microvolts, 30 microvolts, 100 microvolts, that stayed put, that's perfect. Now our S meter needs to be 9, it says by the way 200 microvolts for S9, but we're not going to set it to that, because industry standard in the UK for a FM CB radio is 100 microvolts, and it is already set spot on to that, so we don't need to twiddle with VR3, which is the RX meter. So I'm going to take a photo of this. I'm going to go and do something else. We'll come back to this, but I'll take a photo of this, and then I'll have hopefully filled in all the pretty colours. Right, so I've done myself a diagram, and hopefully we can just see what's going on here. So I did these multipliers which brought us to the 27 megs, did those with the grid dip oscillator. Then we've got transmit, high power preset, low power preset, transmit, only touch with the spectrum analyzer. They're usually flush or just poking out. Transmit meter, and hidden behind there is deviation. Then on receive, we've got the detector, we've got the two front end for your receive, there's an IF there, and this, looking at the circuit diagram, is the squelch receive detector. It's got its own detector. I twiddled it and it didn't make any difference to me, but you shouldn't have to ever touch that. Receive meter, squelch minimum, squelch normal, and this is the receive 10.24 injection from the synthesizer into the IF, so that can be tuned up along with the IF. So there we go. It's much more complicated than most sets, and you can understand why they're difficult to do. And of course they're bleed over boxes, but I like them. Right, we'll put this back together. Right, so we're on 19. We can hear silly noises in the distance. 19 Roger. Let's see if PA works. Testing 1 2, testing 1 2, 1 2. Well, it does work, and it has a volume control. And as I say, you may think, well, so what? But there's a lot of sets don't. There's no receive light on that. I'm not going to do that. Oh, hang on a minute. That's probably because we're in CB. We're not in CB mode. What a twit. Transmit and receive lights are working. Let's have a flick round. It's about quarter past 5 on Monday. Right, we'll squelch that up, and we'll do that. So we'll be ready for a test with Mr. Chippy later on. So there we have it, the Binatone Route 66, the later one, which is not easy to service, but is much easier to service than the early one, which uses a PLL02A phase lock loop rather than the LC7137 that this one uses. Thanks for watching.